Okay, we're in week 8. Week 8 is the material and rational functions. Hopefully you had a chance to look through the material that was presented to you and study it. And by studying that material, understand what was presented to you, what a rational function is, vertical asymptotes, horizontal asymptotes, slant asymptotes. We did a lot of material with that, sign analysis, general graphing. For the most part, though, we kind of keep it simple. All right, now certainly you may not agree with that until you study it, but you should be familiar with the examples that we presented to you. And we presented a lot with, kind of good graphs to look at. Now, we're not expecting you to draw graphs this good, but your graph should roughly look the same. All right, now when I'm saying roughly the same, a pre-calculus sketch, these are well-drawn graphs because the machine does it. All right, so we went through a bunch of examples, and I know we introduced concepts that may not be familiar with, for example, limits and stuff. You want to start becoming more and more familiar with the concept of a limit, though. All right, so we went through some stuff here. We got through a bunch of example questions. Yes, there were pictures provided to you to help us through that material. At some point, we pull the pictures from you, though, and you should be able to do this on your own. Some questions do require the use of technology, though, because computationally, they may be beyond your skill set. All right, so at this point, all my showing and telling you, what you need to start doing is saying, gee, I wonder, can I do this myself? And you should be wondering that. You want to start to work on the material. And by working on that, you're going to get to a section of notes where it says supplemental activities, which means on your own, you make some attempt to do those problems on your own. All right. So let me get where we are in supplemental activities. I'm going to switch to the whiteboard and we're going to start to work through the supplemental activities. All right. So let me get there. I'm going to see if I can do that. Yep, we're going to do that right now. We're going to start on page number 162. Just give me 1 second. This might take me more than a second, actually. And I got to just open up my whiteboard. And just give me 1 second here. Let me see. And again, we're hoping that you've actually done this already, because otherwise it's pointless watching someone work when you should have done this. And again, it's not me working problems, it's you working problems that's going to allow you to work successfully through the course. All right. So I think we're starting on page 162, right? Make sure of that, 162. And how far are we going to go through this? Ooh, a lot of work, isn't there? Wow. Again, the more time and effort you put into this, the better it is for you. All right. Let's see. And just give me 1 second. I'm going to do another screen share with you. Okay. So I want to point out the questions and we'll go through the work for each question separately. And again, these should be done prior to coming to class or watching these videos over here. The first one says use long division. So let me pull this on the side. And I'll see if I can do that. Whoops, I need to do that there. Pull this over here, kind of blow it up. And it says do long division. Let's do it. All right. And again, long division is something you learn in Math 100. Actually, something you really learn in grade school. But what I mean by Math 100, they kind of talk about polynomial long division, which is really no different than grade school long division. Just more abstract. I think it's easier too. Let's take a look at it. What times x squared would give you x cubed would be x. What do you get there? X. Let's see, what would you get? You get x cubed, right? Plus x squared, and then minus x. And you're going to subtract now. You get minus 3x squared. let's see, plus 4x minus 5. And then I'm going to, what times x squared give you minus 3x squared will be minus 3, right? So it's going to be minus 3x squared minus 3x plus 3. You're going to subtract, you get 7x. And let's see, that would be minus 8, right? Now, what they say, use long division to find a slant asymptote. This will be the slant asymptote. What's slant asymptote? Y equals x minus 3. Look at the answer key, and you're staring at it. All right, let's go to the next one, which was number 2. Number 2 looks a little more complicated, and they give me a picture, which is, kind of, I'm thankful for it. But I've answered at some point, you might be thankful for things given to you, but at some point you want to earn these things, be able to graph these things on your own. All right. So I'm going to just do this, pull a picture out, and pull it on the side. I am going to read the questions to you, though. All right. But as I'm doing these things over here, is that at some point I should be comfortable that I can, come up with these questions without being presented these questions. And, certainly someone says, well, I don't know what the questions are. Well, I'm going to read them to you. But the expectation here is that you've actually done this already, that you've read this, you've understood what you've been asked to do, and you've done it. All right. So, I'm looking at problem. This is problem number 2, and I'm going to go through each question separately. The first one basically says, what is the what is the Y-intercept? So I'm going to say that should be really easy for me to do. And I'll look at the key later. So 2, whoops, sorry about that. What's the Y-intercept? Now, by the way, I'm looking at the graph. I'm seeing it. But I got to be honest with you, graphs can be very deceptive. So I want to go do the work. How do you get a Y-intercept? Set, x equal to 0. Well, let's see if you do that. You get f of 0. That's what y is going to be. And what do you get? 2. And what do you get at bottom? Oh, geez, minus 1. So what's going to be? Minus 2. Well, exactly what we expected to see. We expected to see when x is 0, y is to be minus 2. All right, I want to go over here again, point this out to you. I'm seeing it. I'm seeing it. My work shows it's there, right? Do not believe the graph gave me this, though. My work gave me this. This just reaffirms my belief that the graph is pretty accurate. All right, let's go to the next one. What's the next one? What's the x-intercept? All right, so this is number 2, and this was A. I'm going to go to B now. And what does B say? What are the x-intercepts? Well, to get the x-intercept, also relatively simple. I'm not seeing it. I'm not saying it's not there. I just don't see it. And what I'm going to say is what you do is set y to be 0. Set y equals 0. Now, what do you mean by that, the function equal to 0? Well, what do I know about this over here? Does the function ever equal 0? And the answer is no, it never does. And why is that? 2 divided by, well, there's no number that would make that 0. So I'm just going to simply say none. Again, I don't see one in the graph, and I'm certainly not getting one by computational purposes. All right, these answers are listed for you. All right, the next question they ask about, which is letter C, they say, is there a horizontal asymptote? All right, so someone says, what do you mean horizontal asymptote? You have to know what that means. It means, is there a line that's horizontal? It means y equals something. I'm kind of looking at it, and I'm going to say, I think I see it. I'm thinking I'm seeing a line here, in the picture anyway. And I'm going to say, I believe that line, that horizontal line, is y equals 0. I want to go through the work, though. And what's the work going to be for this one over here? It's going to be limit as x goes to infinity to x minus 1 cubed. I hope you start to realize if I did that and I got really large numbers, it's 2 divided by a large number cubed, which is going to be a really small number. I'm going to say it goes close to 0 really quickly. We also should do limit as x goes to minus infinity 2 over x minus 1 cubed. Well, again, what am I doing? Going towards negative infinity. So the bottom's a negative infinity cubed is a negative infinity. It's still going to be 0. I want to point out, though, that this one would be through positive numbers and this one is through negative numbers. You don't need to know that, though. So I'm going to say this implies that we have a horizontal asymptote y equals 0. It's the horizontal asymptote. So C is done. And again, look at the answer key. What does it say? Make sure if it did this right. A, B. Oh, I'm sorry. That wasn't C. That was D. Sorry about that. C was, what's its domain? I'm sorry. Put this over here. The domain is all real numbers except 1. If you want to write that down in intervals, it's minus infinity up to 1, union 1 to infinity. Why is 1 being excluded? Division by 0. I'm clearly seeing that in the picture too. All right, so let's take a look. And we'll go to letter, I guess we just did A, B, C, and D, right? So we'll go to letter E now. And what does letter E say? What's the equation of the vertical? I'm looking at it, and I'm seeing this over here. Now, I probably could stab at that. I can say x equals 1. And write down black ink. This is vertical line. So I'm going to say vertical asymptote. We'll go through the work, by the way. And this is letter, make sure I'm saying this right, letter E, right? I'm going to say x equals 1. I want to put the work down now. And yes, I know it's difficult. Limit as x goes to 1 from the right of the function. We'll talk about that in a second. And we want to do the limit as x goes to 1 from the left of the function. And yes, I know this is difficult. We're trying to get you guys to start thinking about moving forward. All right, so let me point out what I'm talking about here. We get close to 1 from the right side of it. Now, what does that mean, numbers that are bigger than 1? Well, numbers bigger than 1, minus 1, would be positive numbers, but we're getting closer and closer to the 0. So what are we getting? 2 divided by a very small positive number cubed, which would be an incredibly small positive number. That divided into 2 is going to blow up. So I'm going to say plus infinity. All right, let's go to the next one. I know it's tough. This is 1 from the left side. Well, if you're at 1 to the left side's number is slightly smaller than 1, like, 0.9, well, 0.9 minus 1 would be a negative number, but they're incredibly small numbers. We're getting closer and closer to 0 from the left side. What's it going to be? A negative number, cube, which is a negative number. 2 divided by an incredibly small negative number is going to go off to minus infinity. All right, this is an indication of vertical asymptote. I want to look at the picture though and talk about it. This is the number 1. This is the right side. If we're from the right side, what's happening? This thing is going off to plus infinity. Right side going off to plus infinity. Left side of 1 is going to minus infinity. All right, we got that in the picture over here. All right, let's take a look. What's the range of the problem? It's difficult. I know that, but I'm starting to see this thing. I'm looking at the picture. I'm starting to have a better understanding what range is by looking at the picture. By the way, you could be deceived here. We're not trying to deceive anyone with our pictures. So I'm going to say this is going to be F. Oops, write that down for you. The range of it, and I'm looking at it. I'm going to say minus infinity up to 0. It could never equal 0. We've already discussed that prior. Union 0 to infinity. Again, I'm looking at the picture. Now remember, we've already determined it never hit the 0. So I'm looking at the picture. Certainly, picture of it never hit 0. That looks pretty reasonable to me. Look at the key and make sure you understand these answers are listed in the key for you. All right, I'm going to go to number 3 now. Let me see if I got 3 on this page. No, I got next page here. And number 3, I'm going to put a box around it. And we'll talk about it. And again, I know for some students this is very difficult. We're trying to encourage you to meet these difficulties by moving forward. All right. So what do they want me to do? Find the limit if it exists. And I'm going to talk about it. All right. So limit as x goes to 1 from the right side. And what do you get on top? You get x squared plus 3x plus 5. And in the bottom, you get x plus 1, x minus 1. All right. I just want to briefly talk about getting close to 1 from the right side. I'm going to put a number line down. and right side is this side over here. Okay, when someone says get close to 1 from the right side, you should start to imagine you could actually get so close to 1 that you couldn't tell the difference between something close to 1 and 1. And what number would that be? That would be 1. So if you plug in 1 on top, what would you get? Well, let me go through that. You get 1 plus 3, which is 4, and 4 plus 5 is going to be 9. All right, let me go to the bottom. A little more complicated. If I get close to 1, what would I get? 2. If I get close to 1, what would I get? 0. This is very dangerous, by the way. So here's the deal I got to tell you about this over here. I'm really not touching 1. What am I doing? I'm above the 1. Well, if you got a number above a 1 minus 1, that number would be above 0. So I'm going to say if it's above a 0, it means it's a positive number. So what am I really saying? If I thought about it, what am I saying? 9 halves divided by incredibly small positive numbers. That is going to blow up without bound. And we say plus infinity. I'll write that down for you. All right. I'll put it in black for you. Oh boy, I must have black ink. Sorry about that. Whoops, I did it again. Let me get my eraser out. Oh boy, I'm really screwing up here. I made that way too big, didn't I? I'm sorry. Okay. Here's the deal. Some people look at that and say, really, I have a real tough time with the arithmetic thing. If you like, what you can do, and I want to emphasize, if you like, you can do this, right? If you can follow what I did, that's fine too. Some students are going to need what I call a crutch in doing the problem. And what they do is they tell you, and I'll write this down for you, y is a function of x, and that function is x squared plus 3x plus 5. And what do you get at the bottom? X squared minus 1. What they tell you is to do a table of values. I'll write this over here. The numbers they tell you to choose are these numbers as follows. 1.1, 1.01, and 1.001. What they're expecting to do is to plug it in here using a calculator. Now, let's say you don't know how to use a calculator. Come by during office hours, and we could actually put the camera on, and we could look at the calculator you're using and try to help you with that. We could also show you on the web how a web-based calculator would compute these numbers. It's really simple to do, by the way. And if you did this on a calculator, I'm going to say you can get approximately these numbers. Now, when I do that, I'm not going to say I'm going to write all the digits down, but I'll write down some of the digits. I'm going to say this one will be 45. Again, I'm using a calculator to do that. I'm not doing it in my head. And if I did the next one, which is y of 1.01, I'd get 450.254. And if I did the next one, I get 4,500.25. Now, by the way, before I do anything, I want to point out, if you keep going in this direction over here, I hope you realize you're getting close to the number 1 from the right side of it. If you look at these numbers over here, though, and granted, you might say, I don't know where they're going, but I hope you know they're getting bigger. Like you see 45, 450, 4,500. Probably the next guess will be 45,000, 450,000, 4.5 million. Where are they going? Infinity. Exactly what we said it is up here. All right. We would prefer that you think about it, though. All right. Let's go to number 4. And I'm going to put a box around it. And these are really not bad problems. I'm going to read the question to you, though. All right. And yes, we're expecting you to read that too. All right. So let me put down, each thing separately. And what does A say? It says rewrite it as a single fraction problem. And I'll put that down for you. Equal, we'll check the key later, x minus 1. Then you would get x squared minus 2 minus 2x plus 2, which would give me x squared minus 2x over x minus 1. And this is letter A. Okay, I am going to recommend that when you're doing homework to look at the key to make sure you can agree that I have that written down. All right. So what I want to read to you again is rewrite fx as single fraction. I've done that. And do the long division. I'm going to do that now. We're still in A. Oh, well, how do I do the long division here? I guess I got to do x, right? X times x is x squared. Then I got to subtract, so I get minus x. And then I would do minus 1 then, right? So we get minus x, and minus 1 times minus 1 is plus 1. I subtract to get minus 1. So if I did the long division, and write this down for you. And again, we'll have a key to look at. People do make mistakes, and that's why it's so nice to have a key. So what do we get? X minus 1 over x minus 1. All right. Again, what I'm going to recommend is you look at the answer key to make sure that you're staring at this thing over here. It is so important that you look at answer keys to verify that you're seeing these two over here. I'm seeing this one here. I'm seeing x squared minus 2x over x minus 1. That's a single fraction. And I'm seeing this thing over here, which is x minus 1 over x minus 1. Not so bad. All right. Let's go to letter B now. I don't know what letter B says. We'll read it to you. It says, what's the y-intercept? So let's letter B now. And how do you get a y-intercept? It's really simple. All you got to do is set x equal to 0. If you did that, you're going to get a point. My claim over here, this is probably the easiest place to plug it in. What would you get? 0 divided by minus 1, which would be 0. I am going to claim that should be clear as day looking at this thing over here. I see it. I'm seeing 0, 0. All right. Again, what I recommend, look at the answer key, make sure you're staring at that. What's the next thing say? The next one says, this is letter C now. What are the x-intercepts? I'll write this down for you. I want the x-intercepts. What do you got to do? You have to set y equal to 0. Well, let me put that down for you. If y is equal to 0, what do you get? Well, I'm still looking at the same fraction, which is x squared minus 2x. I'll factor it, though. And when would that become 0? Well, at 0 and at 2. So I have 2 of them. I want to put that down. I'm seeing it. I'm seeing it. I see them both. All right. Look at the key, though. What does the key say? 0, 0, and 2, 0. So we're kind of rolling along. We got it. All right. Now, what else does it say to do? Again, I'm reading the questions to you. It says over here we're on letter D with the vertical asymptote. Well, it looks pretty easy to do. I'm looking at it. All right. I want to point out I'm looking at it. I'm seeing it over here. I'm kind of looking at it. And I'm going to say the vertical asymptote looks like it's x equals 1. All right. So I'm going to say vertical asymptote. And this is letter D now, is x equals 1. But I want to do the work. And what's that work going to be? Limit as x goes to 1 from the right of the function. I'll write this down for you. It's x squared minus 2x over x minus 1. And I want to do the limit as x goes to 1 from the left of x squared minus 2x over x minus 1. I'm going to get my eraser out, by the way. And the reason for that, I'm going to erase this old work over here. I want to keep the view in, right? The view in. I want to keep the view. All right. So I'm just going to test it out. And someone says, why would you test it out? And see what's happening over here. If you put 1 there, what would you get? Minus 1. I hope you can agree with that. Now, if you put 1 from the right over here, what would you get? I want to point out what 1 from the right means. They're numbers bigger than 1, right? But you're getting closer and closer to 0, but from the right side. What do you get? -1 divided by an incredibly small positive number is going to be minus infinity. So what am I claiming over here? If you approach the number 1, it's the number 1, from the right side, it goes off to minus infinity, exactly as my picture tells me. All right, let's do the next one, which is going to be plugging in 1 again. What do you get on top? You still get -1, but now it's 1 from the left side. If you touch 1, you get 0, but now you're on this side, which your number is smaller than 1. So what happens over here? This would be a positive number. I'm sorry, negative number. I made a mistake there. I wasn't thinking. Let me just back up a little bit. Okay. Now, what am I saying? Like 0.9 minus 1 is a negative number. Negative divided by negative is a positive. It's going to be a very small number on the bottom. It's going to blow up to infinity. So what are we saying? 1 from the left. And what do I mean by that? 1 from the left, this is the left side, goes off to infinity. Seems like it's reasonable. All right. Look at the key. They put the limits down for you, and they write down the vertical asymptote is x equals 1. All right. What else do they ask for? What happens when you get a plus or minus infinity? I'll write this down for you. This is letter. I'm sorry. I have to read this thing myself. The question's vertical. Oh, I'm sorry. E is a slant asymptote. All right. So put that down for you. E is slant asymptote. And we've already done that before. I hope you remember that. What's slant asymptote? Y equals x minus 1. When we go to plus or minus infinity, the graph takes on that. That's this thing over here, by the way. Let me put that line in for you. And again, the reason we give you good pictures is so you can study that, all right? And this is the line y equals x minus 1. All right, pretty simple. All right, and I'm going to just go to the answer key and make sure that's listed for you. Yep. And next up is, I get to read the question to you. What's a domain? And that is letter F. It's pretty simple questions, by the way. What's a domain? All real numbers except 1. Can't divide by 1, right? Because it would make, divide by 0 because 1 would make it 0. So what's it going to be? Minus infinity up to 1, union 1 off to infinity. Again, look at the answer key. Make sure you can understand that answer has been given to you. So I realize that G might be more difficult for you. And what does G say? What's the range of it? But I want to point out, if you're looking at it, I really do want you to look at the pictures that we brought to you. What do you see? You see this curve over here, right? Like this over here, and I get this curve over here. A little arrows there indicating that this thing is going on and on forever. What does it cover? Every single real number in the universe. What's that look like? Minus infinity to infinity. Again, we're looking at a picture. The picture's been provided, but I think you probably need a picture on your own. I really do. All right, the answers are listed for you. So I'm going to go to number 5 now. And let me see if I can do that. Yep, number 5. I'll put a box around it. Oh, let's take a look. Find the limit if it exists. And for some students, this might be very, very difficult to do. But I do want to point out, some of these things are basically, can you use a calculator? All right, can you use a calculator? So I want to put down, they're recommending a table to use. And I'm going to write this down for you. And they're saying x. I'm going to write down what f of x is, though. It's tough. And I realize for some students that have tough times using, machines, that this meant they say can't do it. And it happens. It really does. But anyway, they recommend that you use like numbers like 1, 0.5, 0.1, 0.05, and 0.01. Now, before I do anything, I want to point out, I think if you look at this pattern of numbers over here, I hope you know that these are going to 0 from the right side. You're getting closer to 0. All right. Now, by the way, they tell me to also do it from the left side as well. So I'll put this table down for you as well. And yeah, I know it's a lot of work. And again, this is what they tell you to use. So basically they're saying, can you use a calculator to do that? We don't know yet, right? Now what I'm going to say over here, this is actually going to 0 from the left side. All right, now what they want you to do is compute f of x. What I do know though is I do know that f of x is even. It's something we learned about in the past. So I know if I do f of 1, I'm actually doing f of minus 1. It's going to be the same thing. And I'm going to say this approximately. I'm using a calculator now. 0.236068. 0.236068. Again, if you can't use a calculator, come by during office hours and we'll help you. This next one, if I computed it, would be 0.24. This is approximate, by the way. 6211. 0.24, 6211. I don't see a pattern yet. The next one's going to be 0.249844. 0.249844. I'm going to keep going. I'm going to 0.05 now. 0.249998. This would be 0.249998. And if I did the next one, it would be 0.24. Let me see if I did that right. I'm sorry, I made a mistake over here. This is 6.1, and this is 6.1. 0.249998, and this is going to be 0.249998. All right. Now, someone says, there's so many numbers, I don't know what I'm looking at anymore. We're saying, could you predict? Could you predict? And I'm looking at it, and I'm going to say, it looks like it might be going towards 0.25. It looks like that. By the way, no guarantee. I'm saying it looks like it's going there. Now, what's 0.25? I would say a quarter from both the left and the right. Okay? So I'm going to say a quarter. Now, someone says, I probably could have done that without the computation. We're not denying it. And in fact, we hope when you start to think about these things that you're able to do that as you move forward. All right? What I mean by moving forward is getting there at some point. All right? So I'm going to say that's done. There's a computation problem. Yeah, we're trying to get you guys to use your calculators to see if you can do it. I'm going to go to number 6 now. Let me see where we are now. That's number 5, right? I'm going to go to number 6. Oh, boy, number 6 is right here, right? And I'll read it to you. Okay. Rewrite the function as done in prior examples. I think what they're telling me here is factor in. I'll put that down for you. Boy, this is a deja vu problem, isn't it? I want to emphasize here is that I hate to say this, almost everything you get is going to be deja vu, that you've seen these before. Now, when I say that, I'm not going to say it's the exact same thing, but it sure does look like something we've seen before. So I'm going to say we factored these guys before. What else have we done? We've done long division. All right, we've done it. Let's put this down. I guess I'd say x, right? So you get x squared minus x. That'll be 3x plus 3, right? All right, so 3x minus 3, and you get 3 over there. That's not so bad. Let's write that down. Now, by the way, I can't say this enough times. People make mistakes. We certainly want to make mistakes in exams now. So what I recommend you do is now look at the answer key and see if they've got those answers down. Now, I want to point out to you, do they have this one listed? X times x plus 2 over x minus 1. They do. Do they have this one listed? X plus 3 over x minus 1. Yes, they do. All right. So I'm going to say I'm done with A. This was A. Let me go to B. I'm going to read it to you. What does B say? What's the y-intercept? Couldn't be easier. All right, down. Y-intercept. It's the x to be 0. And what are you going to get? 0. That's done. Okay, someone says, where's the work? There really is no work in that one. I always say it's a no-brainer problem. Look at the key, though. Make sure it's there. Let's go to C. And what does C say? The x-intercepts. Also incredibly easy to do. Was it going to be 0, 0? That's 1. And the other one's going to be minus 2, comma 0. Virtually no work. All right, look at the key. It's staring at you. Let's go to D. What does D say? What's the equation of the vertical asymptote? Well, I'm going to kind of put it down. I'm believing it. The vertical asymptote is going to be x equals 1. Someone says you didn't put any work down over there. We'll get to that later. But right now I'm going to say I'm believing it's x equals 1. All right? We'll come back to that later. Let's go to letter, what letter are we on now? I guess we're on letter E, right? What's the equation of slant asymptote? I could put that down. A, B, C, D, E, right? Where am I seeing that? Right up here. Okay. I got to put work down for D, though. I haven't done that yet. And let me see if I can get this next one up here. What's the domain of it? Well, that's pretty easy. It's all real numbers. X can't be 1. You can put an infinitesimal if you like to. All right. What's the next guy up? I got to read the question. I got to find it. I got the domain. Oh, the range. That means I got to get a picture. All right. Let's see if we get the picture down. All right. That'd be a great picture. I'm going to put down that vertical asymptote x equals 1, right? That's done. This is x equals 1. I'm going to put down those x-intercepts and the y-intercept. Whoops, made a mistake already. All right, this is minus 2 over here. All right, I'm going to put the slant asymptote down, which is x plus 3, which means I have something up here like this. And then something like this over here. I'll put this over here. Yeah, I'm drawing over my work. All right. Let's see if we can draw a picture now. I know it's tough. That's why I can't draw the picture. We want you to try. Now, I'm not saying it's going to be easy, by the way. And I'm looking at it, and I got to get these things to connect together. But I'm starting to think that maybe I could probably do this over here. Right? It's going toward this. I know it's going towards this as well. Going towards the slant asymptote. All right, now let's just talk about, the sign analysis and the problem. And I'm going to talk about, looking back at the original problem, this guy over here, and talking about the sign. And the sign I want is what happens after the number 1. Now, you might wonder why I'm doing that. Look at the asymptote. And after the number 1, I'm going to say everything is positive in the problem. So it's got to be positive over here as well. Okay, I'm not saying I got it right. I am going to put down some work down for the vertical asymptote over here. Limit as x goes towards 1 from the right side of the function f of x goes to plus infinity. How'd I do that? Sign analysis. All right, now let's go from the left side. The limit as x goes to 1, left side f of x. I'm sorry, left side of 1 of f of x. Well, I'm thinking about it. If you're at the left of minus 1, what are you getting at? I'm sorry, left of 1, you'd get positive on top and you'd get negative on bottom. So it's minus infinity. All right, I'm going to put that down now. All right, connect it together. Here comes another problem. If you're between minus 2 and 0 and you plug it in, What's the sign of the function? Well, let's go back and look at it. And between -2 and 0, I'm going to get, like if I did -1, I'd get negative on top. Oh, I get positive because the bottom would be negative. I would say something like this maybe. I don't know. Here comes my problem now. What happened below -2? Well, I'm looking at the picture. It's got to connect up. And how it's going to be? It's certainly going to be negative. All right, so I'm going to say this over here. Here comes my real problem. And this is a big problem. You don't have the skill set to determine what the range of the problem is over here. So G, you don't have the skill set. No skill set yet. And I'll tell you why. You don't know what these numbers are. You don't know what they are. So you cannot determine it. All I can say is it's not all real numbers looking at my picture. It's not looking at the picture. What's missing? This thing over here. So this is where you want to learn how to use technology. Determine these things. What's this thing over here? It's a local min. What's this thing over here? It's a local max. All right. Again, if you're using technology, and what I mean by that, using some kind of computer system, you'll be able to get approximate numbers. When you take calc, though, you'll be able to get the exact numbers. All right. Technology, approximate at this point. You can also get exact too in technology, but a little more difficult. I do put some sage code for there, but I do point out by inspection, you're going to have a tough time determining the range of the problem. The fact that you wouldn't know it's all real numbers. All right, let's do number 7. It looks like a deja vu problem over and over again. Let me see if I can do that. And where am I now? I think I just did this. And I'm on number 7 now. I can just box this whole thing here. Pull it aside. Again, it's really deja vu. We'll talk about it though. What do they want you to do? I'm going to point out the computation. It looks like a very similar problem that we've had before. They want you to use values going towards minus infinity. And I want to point out what that means. This is x. I'm going to put f of x. F of x is, I'm just copying, by the way. And the x's they want you to use are, and they're going to minus infinity, they're saying minus 10,000, minus 100,000, and minus 1,000,000. I hope you realize if someone's counting like that, they're definitely going off to minus infinity. Here's the trouble, though. Can you compute this over here? This is where a lot of students struggle. If you are struggling, I want to recommend come by during office hours, and we can do a one-on-one session to determine how to do this on a computational device. Right, your computational device, by the way. We do recommend using computers, though. I'm just going to say if you did the computation, you would get approximately and you should be able to predict that this looks like it may be going towards minus 0.5, which we know to be minus 1/2. All right. Granted, can a machine do that? Of course it can. We're looking for you to be able to compute with that. That was number 7. We're going to go to number 8 now. Oh boy, 8 looks like a tough one, doesn't it? So what I'm going to do is I'm going to go to the next page, and I'm going to just box that picture for you. And we'll talk about it in stages. Okay, so I'm gonna again, this is problem number 8, and I'll write down for you. And I know what f of x is. I'll write over here. F of x equals, it's written down. I'll write down it's x squared plus 2x. I'll go through the questions separately too. and the bottom is 3x squared minus x minus 4. I think it really does pay to factor them if you can. And the top factors nicely to x plus 1 times x plus 1. And the bottom factors nicely to 3x minus 4 times x plus 1. Let me just check that. The top would be x squared plus 2x plus 1. That looks good. 3x squared, 3x minus 4x is 1. I'm sorry, 3x minus 4 minus 1x. That's good. Yeah, looks great. All right, let's go through the questions one at a time. Make sure we can do it. What's number one? Or I should say letter A. It's fairly simple. They asked me for the y-intercept. How do you get a y-intercept? Set x to be 0. And if you did that, you would get minus 1/4. Very simple computation. Let me look at it. And I kind of agree with it. I'm seeing it. All right. Now you got to plug it in, of course. It's an easy computation. Let's go to B. What does B say? What are the x-intercepts? Also incredibly easy to do. That's when the y becomes 0. The y is only 0 when the top is 0, and that would be at minus 1. Let's take a look at it. And yep, I'm seeing it right over there. I definitely see it. I'm seeing those 2 points. All right, why do we give you pictures? So you can start to learn by looking at the pictures. All right, let's keep reading it. What's the next thing saying? What's the domain of it? This is C, relatively simple question. What's the domain of it? I'm going to say all the real numbers except where the bottom is 0. Where's the bottom 0? At x equals minus 1. And the other one is where x equals, let's see, what would that be? Let's see, minus 1. Boy, I got troubles now. I'll tell you what my troubles are. If x can't be minus 1, this can't be. I'm going to say none. Someone says, why do you know that now? Well, before I just kind of plugged it into the top, I said minus 1 makes it 0, but unfortunately the bottom is simultaneously 0. So minus 1 can't be in the domain of the problem, division by 0. And what's the other one going to be? X can't be. All right. What x can't be? X can't be, let's see, 4/3. We're going to look at the key a little bit later. I'm going to correct my little picture over here. We have conventions. Hope you remember from lecture that this can't be there. So what am I going to do over there? I'm going to put a circle there. There's a hole there. There's a hole. All right. I want to look at the key though. Before I move forward, more difficult questions, see how we did. I got this right. I got this right. It says none. And let me see if I got I got this right too. All right, I'm going to keep going. I want to go to letter D now. And what's letter D? What's the equation of the horizontal asymptote? So it's going to be D, horizontal. And kind of looking at the picture, I definitely see it. I'll put this over here. And that's going to be y equals some number, right? Y equals. Let's take a look at it. Now, I'm getting more comfortable with this. The limit as x goes towards infinity. What we told you to do in class was to divide by the highest degree variable. This would be 1 plus 2 over x plus 1 over x squared. The bottom would be 3 minus 1 over x minus 4 over x squared. Well, that's nice. This is just 1/3. So we get y equals 1/3. By the way, we also want to recommend you look at the limit as x goes to minus infinity. Push this up a little tiny bit. Same thing, divide by the highest degree variable. Still 1/3. All right. Certainly my picture represents that. Look at the key, and it does say that. It has both limits written down. Okay, let's go to E. I think we just, oh no, C. Did I do C? Oh yeah, I did C. I'm sorry. We just did D. Now I'm going to go to E, right? What's equation of the vertical? Well, I'm looking at it, and I'm going to put the verticals over here. I'm going to go right ink out. And what's my vertical? Looking at it, I'm pretty convinced it's x equals 4/3. All right, I'm going to write that down for you. This is letter E. And letter E is x equals 4/3. I do have to write down 2 limits, though. The limit as x goes to 4/3 from the right and the limit as x goes to 4/3 from the left. Well, you know what? They gave me a picture, and I want to talk about it. So let's see. This is 4/3. Sorry about that. This is x equals 4/3. This is the right side. Where's it going? Plus infinity. Put that over here. All right, let's keep looking at it. This is x equals 4/3 from the left side. Where's it going? Minus infinity. Okay, let's keep reading the questions through. What's the range of it? Generally speaking, it's more difficult to do. I'm not saying it's not, but kind of looking at it. Again, when I say looking at it, I'm looking at the picture. And this is the picture we're talking about. It's not easy, though. I know that. And people get it wrong. No doubt about it. We'll talk about the range. And that's going to be f. We have a key, too. We can look at the k, f. So I'm going to say it certainly goes towards minus infinity. And then it goes up. Unfortunately, it never hits the 0. Then it goes above the 0, but doesn't hit it. And it starts to go to what line? The line would be 1/3. It doesn't hit the line. And then what does it do? It goes above the line 1/3. Let me point out what I mean by that. It goes above it over here and off to infinity. Look at the key. Make sure you can agree with that. If you can't agree with that, there's probably something wrong. So what does it say? You'll need the graph, and we got the graph. It should be clear that the range is all the real numbers except 1/3 and 0. And I did write that down in interval notation for you. All right, let me go to number 9. And number 9, again, gives me the graph. So if I can do that for you. And again, we're trying to learn. And I'm going to make sure you know what I mean by learning. Let me get rid of that here. Push this around a little bit. All right, let's see if we can do it. Okay, graph. Figure 66, page 170. I see that indicate what you've learned. So about the graph, a rational function. Wow. Well, I guess we could do a lot of things, but I'm seeing that graph there. It's staring at me. All right. So one thing I want to do is just really quick without wondering what the questions might be. Easy things first, right? I would definitely set x to be 0. Super simple. What do you get? Well, you get 3/2. If x is 0, you get 3/2. We're looking at this. If x is 0, you get 3 divided by 2. I'm going to put that point down. 3/2 is going to be 1.5. I'm seeing that. That's done. I'm going to say it's really easy to do. Now, what I noticed about the top, by the way, it's a fourth-degree polynomial. And certainly if I were trying to do that, I would wonder, like, does it have any zeros? Now, let me write that down for you. I wonder if the top has any zeros. I'll write this down. 3, whoops, sorry about that. All right, I'm going to make a substitution. I'm going to let u equal x squared. And what do I get over there? I would get 3u squared minus 5u plus 3 equals 0. Use quadratic formula. Let's see, twice the a, that's 6. Opposite of b is 5, plus or minus. I know it's work. We're going to put work down. Let's see, 25 minus 4 times 3 times 3 is 36. Well, right now, I know this is complex. And I'm looking for a real solution to the problem. There's no real solution to the problem. There are no zeros. So there's no x-intercepts. So what do I know? I know there's no x-intercepts. So there's going to be, looking at the graph, it's either going to be always above the x-axis or always below the x-axis. How do I know that? This problem over here, the domain of it is, whoops, sorry about that. The domain of this problem is all real numbers. How do I know that? The bottom has never going to be 0. Never. It's x4 plus 2. That only has a complex solution as well. So looking at it, bottom's always positive. The top's always positive. So I know f of x is always going to be a positive. Right? All right, what else do I look at? Again, we're just talking about what you know. What we know now is the thing is always above the x-axis. We know it has a y-intercept, no x-intercepts. What am I going to look at now? I'm going to look at is there any horizontal asymptotes? How do I do that? Limit as x goes towards infinity. Divide by the highest degree variable. What do you get? 3 minus 5 over x squared plus 3 over x4. 1 plus 2 over x4. Well, if you thought about that, if things are getting large, it's going to be 3. So I'm going to say horizontal asymptote is y equals 3. You could also do limit as x goes to minus infinity. And what do you get over there? 3 minus 5 over x squared plus 3 over x4. What do you get on bottom? 1 plus 2 over x4, which again is still going to be 3. 3 divided by 1 is 3. So I know that much. I'll put this down. And I'll put y equals 3. Okay, I'm going to point out what I do know. I know there's a point there. I know there's a line over here that the graph will approach when you go to plus or minus infinity. So if I were to put that down in sort of like my notation, I may not know exactly what it looks like, but I'm going to say over here is I know whatever this graph is doing, it's getting close to that line. Okay, what else do I know? I know f of x is even. I'm going to point out what that means. F of x would be the same thing as f of minus x. Well, look at it. It's the same thing. What do I know? Folding symmetry about this line over here. And here comes the problem. I don't know how it connects together. All right, so I'm going to say over here is whatever you do put down. Well, I can say it's an accurate graph. You just don't know that yet. You don't have the calculus to know that. If you were to graph this guy now, you might do something like this. That would be a fine graph. But I want to point out, you really should start thinking about using technology to connect it together. And if you did it, it would look more like this over here. All right? All right, let me just undo some of this stuff over here. Again, let me point out what you do know from pre-calculus. This behavior, this behavior, this behavior. You know it's positive on both sides. You know it's even, folding symmetry. What you don't know is the connection. So over here, I want to point out technology is going to allow you to get that connection. When you take calculus, though, what you're going to start to do is you're going to be able to start to determine what these points are. You'll be able to show that's a global or relative minimum. You will be able to show in calculus that this is a local maximum. You would be able to show in calculus that there's going to be sort of shapes of these curves over here. Concave down, concave up, concave down, concave up, concave down. You're able to do that and also determine points where those concavity changes. Right now, though, you don't have much tool sets over here. We're just doing the pre-calculus. That was question number 9. What I'm going to do is go to question number 10 now. Number 9 is done. And we'll do number 10. And number 10 is I want to point out what it is. It's use a graphic utility. And I guess what I'll do is I'll use a graphic calculator to do that one. Let me see what number 11 is. Oh, I'm going to go to Sage now. All right. I should say Sage. I'm going to get to use a software. All right. So let me switch screens. And, you know, I'm going to use Grapher. I realize many students here don't have access to a computer that has Grapher built in, but I wouldn't worry about it so much. And I'll go to different software. But I want to do number 10. All right, number 10. So I'm going to type it in, X. I'll also do it on web-based system. So I'm going to square root. And the square root of x squared plus 1. All right, now looking at it, what I want to claim over here, I'm kind of looking at it, and I got a pretty good idea that this thing has asymptotic behavior. Just looking at it, I know that it looks like the domain is all real numbers, but I'm going to put some asymptotes in, okay? Let me put this down for you. I'm going to say it looks like y equals 1, all right? I'm also going to say another asymptote looks like y equals minus 1. All right, I'm going to make these things dashed lines. And maybe I'll make them red. I can make them dashed lines. Let me get rid of this stuff here. I'm going to zoom in. I'm going to get rid of the grid because it disturbs me. Okay. So I want to point out that's my picture I got there. Now I want to go to the questions, and you know it says over here you should make sense out of what you're seeing in the graph. And I'm going to try to make sense out of it. One thing they say use sign analysis. I'm going to say at 0 it does change its sign at 0. So to the right of 0 it should be a positive curve. To the left of 0 it should be a negative curve. Let me just pull that graph in front of you again. I'm seeing it's positive to the right, it's negative to the left. I definitely see that. What else does it say to do? You know, limits, sign analysis, domain, fairly simple stuff. I would recommend you read through that. I also want to go to the web. I'm skipping Sage for a moment, by the way, and there's a reason for that. I want to go to Wolfram, and this is Wolfram Alpha, something we've been talking about for a long time, and I want to plot it out. I want to see what kind of job it does. And I'm going to graph, I'm going to say graph. You don't have much control with Wolfram Alpha, though, and that's a problem. And y equals x divided by the square root. And that's going to be x squared plus 1, right? Yeah, you have to learn how to type. That's true. Take a look. Yeah, I'm seeing it. And they give me sort of like pictures over here of it as well, a little different. They're not putting the asymptotes in over there. You get the idea. There's less flexibility. What's the nice thing about using commercial software? Good deal of flexibility in what you're doing over here. All right, that kind of covers it out. Again, if you have questions or you're totally confused, please come by and see me during office hours and we can try to help you with that. Thank you.